Section 2.2, our first problem will be write the equation in slope-intercept form, identify the slope and vertical intercept. So this is one where we've given you a equation that's not x and y. So we have to tell you which variable is the dependent variable. And it says here that t is the dependent variable. So remember, the dependent variable means the one that you want to solve for. So when we get this solved, we want to wind up down here with t equals something. So that's what t is the dependent variable tells you. It means solve for t. So you know from all your equation solving skills, the first thing we're going to need to do here is distribute. So I'll write it a little bigger here so you can see it better. So this is my original equation. And I'm going to distribute the two. So now remember, we're solving for t, so that means I'm going to move all the t's to the left and move the w's to the right. So I can start with either one. I can move whichever one I want first. So I'm going to just start with moving the w's off to the left. So I'm going to do minus 5w on both sides. That's going to give me negative 3t equals negative 3w plus 2t. So now I want to move my t over from the left side. So I'm going to do minus 2t minus 2t. Be careful when you do ones like this. I see a lot of people make mistakes when they do this. So negative 3t minus 2t makes a negative 5t. And that's equal to 3w. So now we just need to divide both sides by negative 5. Oops, that should have been negative 3w. So we're going to divide both sides by negative 5. And then we end up with t equals negative 3 over negative 5w. And that's really t equals 3/5 w, or 3 over 5w. And then if you want to think about it, because remember our task was to put this in slope-intercept form, well, that is the slope-intercept form. If it helps you to think of it, you can think of this, because remember the slope-intercept form is y equals ax plus b, where a is the slope and b is the vertical intercept. So that means this that we've just written is the slope-intercept form, and then once we have that, we can read right off of that that the slope is 3 over 5 and the vertical intercept is 0. And remember, technically the vertical intercept is a point, so really it's 0, 0, because it's where we cross the y-axis. The x-coordinate of a y-intercept is always 0, and then this 0 is the one that went there. So if we go back up to our original problem, it says write in slope-intercept form, identify the slope and vertical intercept. So we had to look at t as the dependent variable. We solved for t. Down here was our equation. We can read right off of that. The thing sitting in front of the independent variable is the slope. The thing being added to that is the vertical intercept. So how would we graph the previous equation? So let's go back and remember what the equation was. Down at the bottom here, the equation was t equals 3/5 w plus 0. So if you start off with an equation like that, the way to graph it is first remember what this meant. What we just talked about, that's where it crosses the y-axis. Well, in this case, it crosses right at 0, 0. So then our slope is 3/5. And remember, slope is always rise over run. So that means I'm going to label my axes here. So my independent variable is w, my dependent variable is t, and then I've got to label my scale. So I'm going to do it like this. This is 5 out here. I'm going to call this -5, call this +5, and call this down here -5. And now I've labeled my axes and my scale. And so that tells me how I can use the 3/5. So now that's rise over run. So I start from my vertical intercept, rise 3, run 5, and I make another point. And then I'm going to connect those 2 points with a line. So this may be a little crude. I'm going to do one more point down here so I can get this better. And then I'm going to connect with a line. Yours is probably going to be straighter than mine. And then I put my arrows at the ends of the line, so remember that that line goes on forever in both directions. So now if we have a graph and we want to find the equation in slope-intercept form, we're doing the reverse of what we just did. So we know that our equation is going to be in the form of y equals ax plus b, but really we know that y is the dependent variable, x is the independent variable, and on here our dependent variable is p and our independent variable is q. So we're really going to be looking for p equals aq plus b. Same idea though. This is going to be the slope, and this is going to be the vertical intercept. And we're just going to be able to read those off the graph. So the easiest thing to read is the vertical intercept. So you have to look carefully at the scale. And the scale here, I don't know if you can see it well, but this says -0.4 and this says -0.8. So that means I'm going to start out writing what I know in this equation. So I don't know A yet, but I know my vertical intercept is -0.6 because it's halfway in between those two marks. Now I want to get my slope. So I'm going to pick another point. And I have to look carefully at the scale. So this says -80. And this here says -40. So this point we're working off here is at -60. So now I'm going to do, my slope is always rise over run. So going from the left point to the right point, what did I have to do to get there? Well, I have to drop down on this axis here. I'm interested in how far I have to drop down. So I dropped down -0.6. 0.6. And then I go over, now I'm looking at this axis, and remember this was negative 60, so I'm going over negative 60, oh, excuse me, positive 60. I'm going to the right, so it's a positive 60. Now I said in the last thing that I wanted you to leave things as fractions. One exception to that is we don't like fractions that have decimals inside the fraction. So we're going to go ahead and divide this one out. And when you divide it out, negative 0.6 divided by 60 gives you negative 0.1. So I picked a problem like this that had complicated numbers because I don't want you to get intimidated by complicated numbers. It's just rise over run. You read carefully, read the scales carefully. Don't count squares. I mean, you do count squares, but don't use that square count in your rise over run. You have to think about each square represents how much according to the scale that's on the graph. So our rise over run turned out to be negative 0.1. So now I take this equation up here and put in what I now know as my slope. So that means P equals negative 0.1 times Q minus 0.6. So I just copied down the previous equation, stuck in my new slope, negative 0.1, and that's my slope-intercept form. So that's what we were asked for, write the equation in slope-intercept form of each graphed line. That's our slope-intercept form of the graphed line. So this is like the thing we talked about before. What's the slope-intercept form? Well, this is the line. Put it in red here so you can see it better. That's a horizontal line, so we know it has the form y equals, this is negative 4, that's negative 8, so that means that line goes through negative 6, so y equals negative 6, and that actually is the y-intercept form. If that's confusing to you, think about it's a horizontal line, it has a 0 slope, so you could think of it as y equals 0x minus 6. That means, just like before, here's your slope, 0, and here's your vertical intercept, where it crosses the y-axis, and that's negative 6.